standard signals. These signals are real-time user signals, right? So in that, one signal is exponential signal. One of the very, very important signal, exponential signal. Because generally, practically available signal is exponential signal. Exponentially increases or exponentially decreases. See, up to now we have discussed just like one straight line, right? Straight line means constant amplitude, and with this a slope, signal goes like this, a straight line. But practical cases, exactly straight line signals are not possible, right? So that purpose here, practical cases, the increasing amplitude or decreasing amplitude is just like it acts as one curve shape. So to represent those type of signals, here we have to use one standard representation, that is using a exponential representation. So this signal is also called as exponential signal. And the exponential signal is generally available in two different formats here with respect to time axis. With respect to time axis, here this is positive time axis, this side negative time axis. Similarly, now I want to draw one more here like this. Positive time axis, negative time axis. Exponential signal graphical representation. One possibility is this exponentially decreases, it should be like this. Exponentially decreases. So with respect to time axis, the amplitude of the signal is decreasing, and it's not exactly straight line, it's with some exponentially representation is there. So that's why these type of functions are called exponentially decaying function. Exponentially decaying function. Now sometimes possibilities are with respect to time axis, the amplitude of the signal is increases here. The decrement should be like this, exponentially increases here, right? So this type of functions are called exponentially increasing function. So to represent all these purpose, we have to use one standard mathematical equation, that is e to the power of minus at, and here e to the power of plus at, right? E to the power of minus at and e to the power of plus at. So minus a means here negative value is there. So negative power. Exponential power consists negative, then this acts as a exponentially decaying function, and if the power of the exponential signal is positive, then it acts as an exponentially increasing function. Now I want to substitute few values in this here. If you substitute exactly t is equal to 0 in this, if you substitute t is equal to 0 within this function, let us take here t is equal to 0. So here t is 0 and here is t is 0. Then what happens here? E to the power of 0, right? E to the power of 0. Something power 0 should be always 1, right? So exactly at the origin, the amplitude of the signal is how much here? 1. And this side I am applying here. T is infinity now. T is infinity means it gives the like this. T axis is infinity. If you substitute here infinity value, infinity into minus, so it becomes minus infinity. So e to the power of minus infinity. E to the power of minus infinity value is how much? 0. So please remember, these are some standard values. E to the power of minus infinity, it should be 0. And similarly this side I am substituting t is minus infinity now. Time axis is minus infinity. So if you substitute here, minus minus becomes plus, then it becomes e to the power of infinity this side. So if it is e to the power of infinity, e to the power of infinity value should be always infinity. So now this amplitude becomes here infinity. Exactly at time is minus infinity, this amplitude is infinity, and time is equal to 0, this amplitude is 1, and time is positive infinity, then amplitude is 0. This type of signal is called exponentially decaying function. And similarly, in this case, now the function is e to the power of plus at is there. If you substitute here t tends to minus infinity, this becomes e to the power of minus infinity. So e to the power of minus infinity is how much here? 0. So that's why it starts from 0. Now the function goes like this, 0 to up to infinity. This function is called exponentially increasing function, and this function is called exponentially decreasing function. So now onwards, we have to write the functional representation is like this. X of t is equal to e to the power of at. This is exponentially increasing function, right? And x of t is e to the power of minus at. This explains the exponentially decaying function. Exponentially increasing function and exponentially decaying function. This is another standard signal. And in practical cases, generally used another function is one of the very important function. This is gate signal, or we can call it as a gate function. And another name of this one is rectangular function. Rectangular function or rectangular signal. See, according to the shape of the signal, we have to give the names here. So here, the signal is exponentially decreases, exponentially increases. That's why the name of the signal is exponential signal, right? Now, here I have wrote one more function, that is gate function. That means, in particular time period, it acts as a high voltage, high signal, and other than the time period, it is 0. That means, just like it acts as a rectangular shape, that's why the signal is called rectangular signal or rectangular function. This should be like this. With respect to time axis, the signal is defined in particular time period, right? So, particular time period, it should be constant amplitude. How much amplitude is there? A amplitude. This is defined from negative time axis, from minus t by 2 to up to positive time axis, up to plus t by 2. So, within this time period, from minus t by 2 to plus t by 2, within this time period, it has constant amplitude. Other than this, the amplitude is 0. This type of signals are called gate function or rectangular signals. Because within this time period, it acts as a on, means it acts as a opened, and remaining conditions, it acts as a closed circuit. So, particular time period it is open and remaining time period is closed. Generally the gate operation is like that. So that's why the name is here gate function. And the shape of the signal is just like one rectangular shape. That's why the name of the signal is here rectangular signal, gate function or rectangular function. Now I'm writing here, this is graphical representation, right? Similarly, we have to define functional representation. So the functional representation explains like this. X of t is equal to constant amplitude A. So x of t has constant amplitude. This amplitude is defined from minus t by 2 to plus t by 2. That's why, so minus t by 2 less than or equal to time axis less than or equal to capital T by 2 plus t by 2. So here capital T, what is capital T here? The time period of the signal, because this signal is defined up to particular time period. From here to here it has some gap. How much gap is there? T gap is there. The t is a constant value. Let us take t is 4. T is 4, then it is defined from minus 2 to plus 2. Let us take t is 6, then it is defined from minus 6 to plus 6. T is 10, this is defined from minus 5 to plus 5. So, this time period is a constant value, then this is defined from minus t by 2 to plus t by 2, constant amplitude is A. So, remaining time period it should be 0, that's why I am writing here elsewhere. Elsewhere means other than this time period, greater than the t by 2 and less than the minus t by 2. So other than this time period, the signal is not defined. Signal is not defined, meaning is the amplitude should be 0. This signal is called a rectangular signal. Now here I have wrote exponential signal, means one functional representation I have wrote like this, e to the power of, right? E to the power of minus at, e to the power of plus at. So immediately we can write whenever the signals are defined like this, e to the power something, then it is an exponential signal. Similarly, here also we have to write one standard representation, right? So using that functional representation, immediately we have to find out it is a rectangular function. So the rectangular function standard instantaneous equation is like this: a rect of small t by capital T. See, rect of R-E-C-T. Whenever R-E-C-T is given, immediately we have to take that is a rectangular function. The rectangular function has constant amplitude. How much amplitude? A explains the maximum amplitude. And this amplitude is defined within the particular time period. How much time period? This explains the time period. And what about this one? That explains the time axis representation. That is independent variable, right? So this axis is t here. That's why we have to write with here t. If suppose one function is defined like this, x of t is 2 into rect of t by 8, then draw the graphical representation of the signal. So how to draw the graphical representation? Now the function is rect is there, so it is a rectangular function. Draw immediately one rectangular function. So rect is there, so rect means it is a rectangular function. So draw one rectangular function. It should be like this. So how much amplitude? So amplitude is here 2. So write here 2. Then what are the time limits? Here the total time period is 8 is there. This time limit is minus t by 2. So minus 8 by 2. So this becomes minus 4 and this becomes here plus 4. So immediately we have to draw like this. Because sometimes our expected questions are these type of questions. Functional representation is given, then draw the graphical representation. Then immediately you have to draw this one. Or sometimes our expected questions are graphical representation of the x of t signal is given below. The graphical representation of the x of t signal is given below. That should be like this here. So it is defined like this. Right? Then write the functional representation of the signal. So this signal is a rectangular signal. Rectangular signal amplitude is how much? 1. That's why I'm writing 1 into rect of t by. Total time period is how much? Minus 3 to plus 3. So total time period is 6. So we have to draw like this. So this is another standard function, rectangular function, and this is exponential function. Similarly, we have to discuss some other standard signals. So standard signals are exponential signal, gate function, sinusoidal signal, signum function, sinc function, triangular signal, square wave signal, sawtooth signal. All these are comes under standard signals. So up to now I have explained here only 2 signals. Similarly, we have to discuss some other signals. So please take